It's my pleasure to introduce the next speaker, who comes from the academic and entrepreneurial world. His name is Tomasz Malisiewics. I hope I pronounced that somewhat correctly. Tomasz got his PhD at CMU. His advisor was Alyosha Efros. And later he did a postdoc at MIT, and he started his own company and a very popular blog involving artificial intelligence and computer vision. I think a lot of people here read it. And most recently, he has joined Magic Leap, an enigmatic and very interesting company. And perhaps we will get some insights into what they are doing, if we're lucky. So thank you, Tomasz.
All right, Serge. Thanks for the introduction. I think it was great having Heather sort of talk a little bit about the user experience of VR and AR and mixed reality. I'm going to be talking more about the perception side of things. So for any of the PhDs in the crowd who are interested in building their own VR, AR sort of systems, I'm going to give you guys some guidelines, these things that I found useful in my work for thinking about AR and sort of VR in general. There we go. So Magic Leap, what's Magic Leap? I'm not here today to show you guys sort of demos or our sort of product in action. Sort of, as Heather said it best, we are pre-SDK. The best place to go to find out about Magic Leap is the recent Wired article. They have a really nice description. Even the reporters got to see the demos, and they describe them. I think it's a pretty sincere version of what it's like to experience what the tech sort of looks today. Magic Leap isn't going to sort of show you how the prototypes, the V1s, V2s, V3s, the internal stuff sort of looks like. The goal is to have something that is much more basically ready for consumers. In this picture here, this is Roni Abowitz. He's the CEO and founder of Magic Leap. And what's interesting in this depiction, let's just go back here for a second, is we see light emanating from his eyes. And I think really the best way to think about the magic sauce of Magic Leap is that there is optics technology that gives you the sense that you're really there when you're seeing the stuff on those lenses. But there's also the outward-looking aspect. That's the perception side, meaning that the actual glasses, the goggles, are looking at the world, and they're making inferences about what's sort of happening. So I'm going to show you a quick little video. This is something I'm sure a lot of you have sort of seen already, but this is shot with the true sort of Magic Leap technology, what it is sort of today. This is just going to show you a quick version of what it's like to visually experience the Magic Leap experience when you're wearing sort of the glass. I mean, this is sort of quite simple here. We're seeing a little character that is inserted into the world. This is a much more vivid illustration of what it's like. I mean, the colors, the beauty, that's something that is really missing when you're looking at pixelated screens that are being brought close to you. This is really a breakthrough from the photonics sort of side. And that's really necessary to give people this sort of warm and fuzzy feeling of like, oh my God, this is like the first time you're experiencing sort of something. But in order to make something like this happen, you need to be wearing a device that looks out at the world. So in the remaining part of this quick little talk here, I'm going to talk about basically the road to mixed reality. So I'm going to just let this finish in one more sort of second here. And the way that I see it is that there are three things that we have to solve: virtual reality, augmented reality, and mixed reality. I think of them as a continuum. In some sense, they are three dimensions of decomposing this broad and ambitious sort of mixed reality sort of paradigm. And I'm basically going to equate in the next few slides some research areas. So these are some sort of very well-defined themes for thinking about this and the kind of applications they enable. So the first thing I'm going to talk about is essentially what is needed to make virtual reality happen, and that's head pose tracking. Essentially finding out where your head is in real time. As you're moving your head through the environment, you need to know the 6 degrees of freedom of where your head is. That's something that is important for virtual reality and will then later enable the more complicated forms. Scene geometry estimation is the second bit, and that's something that's also known as mapping. That's basically figuring out where stuff is around you. And the final frontier is object recognition. This is something anybody who goes to CVPR research conferences, this is still all the hype. But this is really something that's important if we're going to have digital content mixed with organic sort of content. So virtual reality requires head pose tracking, as I said sort of before. And really, there are a lot of different terms for this concept. If you come from the robotics sort of community, this might be something that's just called camera localization. Positional tracking is another term that's sort of described for this. And it's an important stepping stone. You're basically figuring out the 6 degrees of freedom of your head in the space that you're in. This is still often done with external tracking sort of devices, things like the Oculus. There's a lot of interesting research questions for how this can be done from a purely visual sort of sense. And only once we have a lot of data does it make sense to apply deep learning to this sort of challenge. We are not yet in this sort of regime where there are big sort of data sets of head pose data, but I think in the next sort of few years, this will be a much more interesting research direction for sort of students to take. Augmented reality is the second sort of stepping stone. I think of augmented reality as basically the scene geometry estimation bit. The number one is the head pose. Once we know the head pose in the environment, sure, you can render things sort of around you. But if you want to insert objects into the world, the machine needs to look at the surfaces and figure out their geometry, their normals, how far are things from you. So this is something where depth sensors are commonly used for these sort of applications. And often number two is solved with number one at the same time. So figuring out the map of the geometry around you and your head pose is done simultaneously. Anybody who's worked in robotics for more than 3 months knows that this is called SLAM, simultaneous localization and mapping. This is still the bread and butter of most of today's augmented reality systems. Now, these SLAM systems are built on top of local features and multiple view geometry insights. It's not yet clear how deep learning and more advanced object recognition tools can come in and sort of save the day. But there's still going to be a lot of ample opportunities for people to try to build better mapping systems using deep learning. And mixed reality, which is sort of the final frontier, is the most sort of exciting one, is the mixing of all those elements. The goal of mixed reality is to leave people with the impression that things were really there. It's almost like we're trying to create the hallucinations. And if you want the object to feel like it's really there, it has to interact with the world. Now, if the object doesn't interact with the world, it has to know what the categories of those things are. If you have a digital pet that you want to hang out with for an hour when you get home from work, that pet might jump on some surfaces and not on others. But that means the device that you're wearing has to be aware of that environment. This is the most exciting part of sort of the whole sort of enterprise. This is still the frontier. This is something that we still haven't seen fully working sort of today. But deep learning is going to be the most important ingredient for this mixed reality bit. I mean, in some sense, deep learning emerged out of the computer vision machine learning community. It is something that I still think of very much as the master algorithm for working with perceptual data. So if you're wearing a device that's going to complement and sort of your experience, you need to have the devices that look out at the world. I mean, this is a typical depiction of a convolutional neural network. These things are quite beefy. They're things that are easy to prototype these days, given an NVIDIA GPU and a powerful sort of desktop. But there's still a lot of challenges in taking all the things that we're seeing work in the deep learning space and applying them to sort of wearables. So for example, better tools to compress the networks, ideas for how do you actually embed these deep learning models into smaller form factors. That's something that still is very much desired by all the sort of the key players in this space. So I advise sort of anybody working in the deep learning space who's thinking about augmented reality to not just make models that are bigger, but sometimes take a step back and make things smaller, sort of shrink them down, explore a scenario where you could remove 90% of the weights in your network while only removing 5% of the performance. Those are the sweet spots that I want everybody to sort of look after. It might be hard to write a paper about that today, but that's really sort of important for the field to progress. So the last thing I want to show you here is, this isn't shot from the real sort of technology, but this is the kind of the mock-up video that Magic Leap sort of put together, but this is really something that we're after. So this is going to show you a little snippet of a game. This is really something that we're sort of after. At our sort of product launch, we want these kind of experiences to be enabled. Short little clip, you can go online, find a longer one, but again, you have bad guys coming down from the ceiling. You have to know where the ceiling is. They're walking around, you have to know where the floors are. If you carefully look at the videos, you'll see that the actual characters are behind other surfaces. You have to reason about the geometry, about the ordering of the surfaces around you. So that's it for my sort of Magic Leap presentation here. I encourage everybody who has more questions about what really Magic Leap is doing to read the Wired article sort of about it. And I also encourage anybody interested in computer vision in general to go to my computer vision blog at computervisionblog.com. Check that out. I usually have updates there about conferences. And thanks for your time.